And what we do in order to crack jobs is we focus on learning frameworks like React, like Angular, like the different other frameworks, but hardly we focus on the fundamentals. And if you have given interviews as a senior engineer, let's say 2+ years experience, would know that there are lots of fundamentals that are asked, and people are not aware of those.
Hello and welcome everyone. Hope you're keeping well and staying safe. This is Hafsanjum and I am working as a community executive at Recro, wherein we are working towards building an exclusive community for developers to help you get connected with like-minded people, build your network and grow professionally. So those who don't know about what Recro is, it is a developer-focused platform helping developers to meet the right opportunity by connecting them with fast-growing startups such as Curefit, Udan, Swiggy, Dunzo, etc. So welcome to Recro Talks today. And today we are having a very special webinar, and the topic of the discussion is web development beyond frameworks, the fast loading time, caching, and cookies, and more. And we're going to discuss in depth, and we are going to have going to witness a lot of examples. The speaker is going to present with us, and it's going to be amazing. So stick with us till the end. Our guest speaker for today is Apurv Khare. He is a computer scientist at Adobe. He's also a web developer with 6+ years of experience in building large-scale applications. He teaches web development and mentors over 100+ students and made them a better developer. Before we start, I would like to make some announcements. And before announcements, Apurv, I think you can just go ahead and say hi to the audience.
Hey everyone, I hope you all are eager to know about what is that I'm going to cover today as web development beyond front frameworks.
Yeah. So before we start, guys, there are a few announcements I want to make. You can post your questions in the question section, and we will take them up in the last 15 minutes of the session, and we will be rolling out the feedback form in between. So do let us know your feedback on the session today. What's something that you liked? What's something that you really found insightful, and that you're taking away from today's session. And keep your notepad handy, and whenever you learn from today's session, post it on your LinkedIn account, post it on your Twitter or anywhere you're active on. Do tag Recro, do tag Apurv, and tag me, and we'll be happy to look at your learnings and takeaways. I think we can get started, Apurv. Let me know if you guys can see the presentation. I think you can share the presentation. Yeah.
Great. Hi everyone. So today we are going to mostly talk about HTTP fundamentals and fast load times. Basically, what we do in our day-to-day life and what we do in order to crack jobs is we focus on learning frameworks like React, like Angular, like the different other frameworks, but hardly we focus on the fundamentals. And if you have given interviews as a senior engineer, let's say 2+ years experience, would know that there are lots of fundamentals that are asked, and people are not aware of those. They are aware of things, how to do things, certain things in React, but they are not aware of how to build system designs or how to just optimize load times and how to optimize the performance of the website. So today we are going to learn that part. So I'll just quickly share what is going to be the agenda. It will be first the HTTP protocol and its versions. Then we'll be talking about cookies. Then we'll be talking about client-side caching. Then we will be talking about critical rendering path and its optimization. And last but not the least, optimizing the first load times. So let's first discuss about HTTP. So what is it? So it was designed for communication between web browsers and web servers. This is long time back in 1990s. So that version was 1.0. Actually, it was 0.9, but 1.0. Those are pretty much similar. So earlier they were just introduced for communication between web browsers and web servers. But nowadays, and since a decade, I guess, it's being used to communicate between any sort of client and any sort of server. When I say any sort of client, any sort of server, meaning, let's say if I have a React front end, and then I have a node middle layer, right, which is a backend for front end sort of thing. That node layer will call different API services. My application is using a lot of different services. Let's say you're using any public API, let's say IMDb API. So you will be calling doing an HTTP request from your node server to the IMDb. Now, since node is itself a server, and you are making a request to another server, so the previous definition that it was just between web browsers and web servers doesn't hold. So the correct way of defining HTTP protocol is to a way to communicate between any client and any server. Now, it is a stateless protocol, meaning that it does not keep any data between the two requests. But it does not mean that it is sessionless. It is stateless. It does know who is logged in, all those kind of data. How? Using cookies and other stuff. So we'll be talking about that later. But make it be clear that it is stateless, but it's not sessionless. Now, it is extensible. What does that mean? So you can, between the server and client, come up with an agreement that this is the header that we are going to use, and this is the meaning of the header that we are going to have. And you can introduce new headers to your HTTP requests. Okay, as long as it is agreed between the client and server, it should work. So that in that way, it is extensive. Now, how does a request message look like? So we will see it practically, and we'll also see it in the, I have shared some code here. So it has some method. So basically there are REST API methods, which is get, post, put, delete. So the first thing would be the method. The second part would be the path, meaning it would be /home, /about, or anything like that. Then the version of the HTTP protocol. Okay, which is the version. There are different versions. We'll be talking about that in coming slides. So there are different versions: 1.1, 2, 3. Okay, optional headers. There are some more headers, like you can have cache control, you can have set cookies, and lots of other headers. A body. So if it's a post, you need to send a body. Okay, so that way you can have a body of the request. I can show you the. I'll just skip this slide and I'll show this part. So here you see the first thing. Okay, which is the header, the method. Second one is the path. So here the path is just slash. It could be /about, /cart, /anything, /products. The third is the version. Okay, then you have the host. You have the these are the different headers that we are talking about, and so on. So now let me go back to the previous slide. So that was the format of the request. Now what is the format of the response? The version of the HTTP that the server follows. See, what happens is when the client sends a request in any version of HTTP, it is not required that the server follows that. It can upgrade to it. It can say that, okay, I do not follow this HTTP request that you're sending, version of HTTP request. So the response will have the HTTP version that they follow. Then the status code. There are different status code. So basically, it could be 2xx, xx, 3xx, 4xx. So 2xx means, let's say 200. So 200 okay means it's good, all okay. 202 means accept. Then 3xx means redirection. Okay, so it could be 304 or anything like that. 4xx means client error, meaning the client has sent an invalid sort of request. This was not expected from the client in the request. And there's one more 5xx. These are server errors. So basically, let's say server is down or server is not behaving properly. Then the server will send 5xx. So these are the different statuses. Now there will be status message. This again a short description of what that was, like accepted, redirected, server error, whatever it is. Then there are different HTTP headers. Then body for the response. Let's say if you are making a request for getting a list of products, then it will commit it as a JSON response. So that's how it works. So entire flow. I'll show the request first. So it's not just theoretical part. This is how it responds. It has the version. Okay, that the server follows. Then the status code 200, which means okay. So this is the short description of the status. Then the different headers that it has. Okay. And at the end, the content. So basically, if you are requesting for if you go to any website, it will definitely give you some HTML. Otherwise, you cannot see anything in the screen. So that is this part. So if I go back, so that is about HTTP requests and HTTP response method message formats. Now we'll talk about how the flow works. So first and foremost things, even before the sending the request or anything, it has to establish a TCP connection. So again, this is something related to networks. We'll not go into depth of it, but we have to establish a TCP connection between the client and the server. Okay. Then we send the request. This is the format of the request, as we already discussed about it: method, path, version, headers. Okay. And then the server response. There are different things, other things are involved, but we are only focusing on the HTTP protocol. So yeah, we'll be talking only about that. So that's how the entire flow of HTTP is, and how the request and response message format is. How to initiate those requests. So if you are in a browser, so you will use fetch API. Now, some of you can also say that you will use Axios. Axios is just a library which internally will use fetch. So yeah, it's fetch API. And then if you are doing it from Node, okay, then you can use Node fetch, which was the previous module which is available. But now we have the new fetch library also, which is there in Node. So either of those you can use, okay, to make an HTTP request. So that is about how do you make the request. Coming to the next part, which is HTTPS. If you see now, most of the places wherever we make requests, it is mostly HTTPS. So I'll just show some of those. Let's say this is HTTPS, right? Here, this is HTTPS. Yep, this is HTTPS. Mostly we have HTTPS. So what is the difference? Right? The difference is that it also establishes a TCP connection, but that TCP connection is over SSL or TLS. Okay, so it is more secure. It has so in TCP connection usually there are handshakes involved. So there are even more handshakes involved, and there are certificate exchange, and there's a certificate authority. Again, I'm not going to the depth of it, but basically this is more secure. So you can prevent some attacks like man in the middle attacks. Like you cannot, not some anyone cannot just decrypt your transmitted message. Okay, so it's just a secure way of communicating. And mostly a good example of this would be banking transactions or online shopping, where you have your credit card details and all those stuff, where there is actually it's required. So that is about HTTPS. Going to the next part. Now these are the different HTTP versions. So HTTP started since 1995 or something. I'm not exact sure, but in 1990s. And the first version was 0.9, and little minor improvements, and it was 1.0. So that was the early days. Okay. Then came 1.1. 1.1 is still widely used. Most of, I would say, more than 50% of the websites still use 1.1. Okay. And then comes 2.0. We'll talk about what is the differences between them in the next slide, but just here I'm giving you an overview. So in the 2.0, they got adopted to the modern web. So there were a lot of things that modern web requires, because now it's not just documents available on the website. It's actual applications are there, which are there on the website. So they had to improve the way of how HTTP communicates between client and server. And then that is 3.0, which is very fairly new. Okay, mostly Google uses it. So it is suitable for streaming media. And if you see nowadays, everywhere we are streaming media, like we have Twitch, we have Zoom, we have YouTube, like most of the things, we are coming more and more online. We are having meetings online, right? This session is online. So that's why this was proposed, and now it's being used. So what are the differences? Why the next version was required? So talking about HTTP 1.0, so it had limitations, meaning there are no persistent connection. Let's say if I want to do a get for, let's say I just went to Hacker News, for example. So here I'll just do a get of the HTML, right? Now when the browser reads the HTML, it will see it requires some script, it requires some image, right? If you see here, it has made some other request for script, image. How does it do that? Because it sees in the HTML that, okay, the HTML that I saw, if you see in the response, let me see the raw. See, if you see the raw response, there will be some link tags there will be some script tags at the end. Yeah, see, script tags, all are there. So it has to make further requests down the line. Now, earlier with 1.0, what used to happen is it used to establish one TCP connection per request. So let's say first it will make TCP connection, it will get the HTML file, it will clear the TCP connection. Now again, one more TCP connection is required for script, again one more for the image, so forth and so on. So with that was a very bad limitation, but earlier that was the requirement. Earlier only HTML used to be sent, again in 1990s. But now later, I would say later of 1990s and start of 2000s, they introduced HTTP 1.1, which had persistent connections, meaning that once the TCP connection is established, okay, it will be a long-lived connection using a keep alive header. So it will have a keep alive header. It will say, for this duration, I want this connection to be established because I'm going to request few more resources from the server. So that was HTTP 1.1. Okay, now the TCP connection don't have to be established again and again between the client and the server for different resources that it requires. Then 2.0 was even more advanced. Like it is very, I would say people started using it in 2012, 13, and so on. Still, I would say 1.1 is still most popularly used, more than 50% of websites. But yeah, what was 2. What did 2.0 have is multiplexing, meaning having multiple requests in the same same instance basically. So it's requesting for the script and the images in the same path. Okay, then there is server side event. So if you are aware of WebSockets, so basically what WebSockets help us to is like the server can send a response to the client without the client asking for it, right? So basically it's a bi-directional communication. Though server sent event is similar kind of thing which you can use with HTTP2, where let's say you generated a report. You went to a website, you generated a report. That report will take around 30 seconds, 40 seconds. Okay. Now you cannot just wait for it, right? One way is to the long polling. The client keeps asking the server like, give it. Is it ready? Is it ready? Is it ready? Or other ways, WebSockets. The third way is server sentiment, where when the report will be ready, the server will send the response to the client via the HTTP2 that okay, that is ready, now you can download it. So that is what HTTP2 introduced. Okay, server sentiment is the major thing that according to me is a very good thing that it was introduced. Then there's header compression, basically to optimize the requests, right? They compress the header, then their prioritization, protocol negotiation, there are lots of other things. Okay. And the third version is the for streaming, which is using Quick. There's another protocol, UUI. It's based on UDP instead of TCP. So I will just give you an example of each of them. So this is Hacker News, sorry, not Hacker News. So if you see in the request, if I go to headers, this uses HTTP 1.1. Okay. Now I go to google.com, I inspect it. If I see the headers, it is using the version HTTP/2, right? And if you come to, as I told you for streaming, right? If you come here, see, this thing it is using HTTP 3, right? So for each and everything, I have given you an example. So for normal website, if it's just documents and stuff, you don't need more. You don't need 2.0, you don't need 3.0, because it comes with its own overhead. So if it's just a plain website like this, you are good with 1.1. There is something which is like application here. If you do a search, right, it has to do some fetching on the fly, right? So for that kind of things, so any application basically which is there, you can use 2.0. And if you're doing streaming and stuff, then yeah, you can go for 3.0. So these are the different examples. Yeah. So that was about the basics and fundamentals of HTTP. Okay, now coming to different headers of HTTP, we'll be talking about two important ones. One is the cookies, one is the cache. First thing is cookies. So what is cookie? Small piece of data that the server sends to the user's browser. Okay, why is this required? Right. It is used to tell if the two requests coming from the same browser are the same or not. So let's say if the browser wants to, so the server wants to know whether the requests that are coming is coming from the same user or a different user. It doesn't have to re-authenticate. Okay, I have to if any request comes, this is a secure transaction, I need to re-authenticate. No, if it has the cookie and if it has a token, let's say if it has a JWT token or any sort of token that you use for authentication, then it does not have to re-authenticate. Okay, so basically it is kind of sort of identifying that who is making the request, right? So that's the purpose of cookies. Earlier, when there was no web storage API, web storage API meaning local storage, session storage, right? Cookies were used to just store data on the client side, which now we do via local storage and session storage. Right? So currently, the purposes of cookies are session management, as I said, login, shopping cart data, personalization, right? User preferences, themes. Let's say if you're logged into your mobile, okay, and you choose dark theme in a website, and then tomorrow you log into a via desktop, and you see dark theme. How does that happen? Because it saw that okay, this is a theme that the user requires, and that is stored in the cookie. So next time, doesn't matter which device you use, it will know okay, these are the user preferences, and I'll use that. Okay. Third is for tracking. Okay, and we have a lot of rules regarding this. If you visit any website which use cookies for tracking, you will get a pop-up that we are tracking. We are using cookies. Please accept. Okay, those are the some laws that are there, like GDPR or the other laws. So they are mandated. So if you are using cookies for tracking purpose, tracking the user behavior and stuff, okay, it's shopping behavior or its interest or what sort of advertisement to serve you, and you have to give that warning. So these are the different purposes for which we use cookies. Okay. Um, Coming to the next slide, how to set cookies, right? So it is sent from the server side. Okay, the server, when it will respond, okay, it will say, so let's say you authenticated. Let's take example of login. So you server knows you're an authenticated user. So it will set a cookie with your login token. So for example, let's say token equals to random string. Let's say JWT token, right? So that's how it will set the cookie. Like this is how it will set cookie. Cookie name equals to cookie value. Very simple, nothing complex. So for example, if the server sends the following cookies, right? I am setting two cookies here: Marvel equals to Iron Man and DC equals to Batman, right? The subsequent request by the browsers will contain all the previously stored cookies. So whatever your server has sent to you, to the client, all the subsequent requests that the client will send to the same server will have those cookies added to it in this format, right? Yeah. So it will have cookies and semicolon separated all the cookies. Marvel equals to Iron Man, D equals to Batman. This will happen in all the consequent requests that the client does to the server. The server will set only once, and then this will happen. Now, because we store sensitive information in cookies sometimes, let's say login the token, right? So if someone uses your token, someone somehow comes across your hacks your website and hacks your browser and takes your token, then they can impersonate you, right? So how to prevent those stuff? How to prevent your cookies? So there are different ways. Okay, first one is to use secure attribute. Okay, so secure attribute is used to make sure that the cookies is sent from the client to the server only via HTTPS protocol. Okay, so it is always secure. So there cannot be a man-in-the-middle attack where they can take your cookie information. Okay. Second is HTTP only attribute. Now, what does this mean? So when when the server sets a cookie and it is stored in the client, the JavaScript can access that cookie using document.cookie. Okay, so if you see this document.cookie, so if I just in my JavaScript code, if I do document.cookie, I can see the cookie. Okay, so what HTTP only attribute makes sure that your cookie cannot be accessed via document.cookie API. So that means if your cookie is HTTP only, the JavaScript that is there in your client side, or if there is a some sort of attacking web JavaScript injected in your website somehow, right? So then it cannot access your cookie, right? And also you should renew your cookie, right? Let's say there's an access token, you would obviously renew it, right? You cannot just forever store it. Let's say 24 hours or whatever is your duration. So you can set an expiration date. Okay. So this is an example over here. Set cookie. The first thing is the cookie itself, ID equals to whatever. Then second is expires attribute, which will tell when exactly to expire the cookie. Third, the next is secure, okay, which will tell it should be only transmitted by HTTPS. The next one is HTTP only, which means you cannot access this cookie via document. Okay. Now coming to the one more important header of your HTTP, which is cache control. The server can instruct proxies and clients about what to cache and for how long. Now, client, we understand client means mostly browsers, right? because we are talking about websites and web application. Now, what does proxy means? So there are two types of proxies. Right? One is normal proxy. Let's say if you are using your internet, so your ISP, internet provider, is your proxy, and one other is reverse proxy, which is on the side of the servers. Okay, so that is for production of the server side. Right? They can have load balancing. They have different purposes, whatever purpose that proxy server is required. So the different type of proxies. One is proxy and one is reverse proxy. Okay, so your cache basically can be stored at either the browser or it can be stored in either of the proxies. Now, what kind of data will you store? Any kind of data which is not going to change over time. Let's say images, okay, let's say your CSS files, anything, which is not going to change over time, right? So that kind of things can be stored in the cache, right? It is used mostly to optimize second and further load times of the website. So when you visit the website for the first time, obviously you don't have the things cached. You don't have the JavaScript bundle cache. You don't have the CSS cache. You don't have any images cache because you're visiting for the first time. But afterwards, whenever you visit that website for second and any number of times, to optimize the load time, you can use cache. Okay. So there are two types of cache. One is private, which is specific to your client. Okay, they're used for the personalized response for the user. Let's say he has some in his home page, he's using some social website. He has a different customized home page, right? So it will be specific to that user only. That those assets will be specific to that user. So it can be stored in your client cache. Right? And then there is public and shared cache, right? Let's say the list of products. Amazon has a list of products, right? So that can be cached in anywhere in proxy or reverse proxy anywhere. So that is known as public or shared cache. Okay. So yeah, so that's the different two main types of cache, I would say, right? Within the public cache also there are different managed cache and stuff, but again that's too much into depth. We are just covering we are not going to that much. So how to store, right? So that is about the caches. What does it do? What are the different types of cache? How do you actually store something in a cache? So when the server responds for that particular asset, let's say image or CSS or whatever it is, so it will have a cache control header. This is the cache control header. Okay, it will have different directives actually. Okay, we'll talk about what this means, but it's pretty much the first one is pretty much understandable. It's max age, like when should it expire. Okay, no cache is not actually what it means. I'll explain you what does it. And that third is public. Public, as we already discussed, it means that it's a shared asset, so it can be cached at any process. Okay, but just let me. Yeah. Next. So different types of cache directives. Okay. Private, as we discussed, only cache in the client browser, right? Public can be cached in proxies. No store. No store actually means don't cache. Okay. And the next one is no cache. No cache means do cache it, but revalidate it before serving. Okay, so it's like do cache the data, do cache that particular asset, but before serving it to the client, just revalidate it to the server. And this is done using a e-tag header. We'll be talking about e-tag header in the coming slides. Then there is max age, as we discussed. It's for the expiration of the private cache. S max age. This is for expiration of public cache. Okay. Then there is must revalidate. So basically, this will say never serve stale content. Okay. It should always be validated from the site. Okay. Now you might think that what is the difference, right? What is the difference between no cache and must revalidate? So in no cache, when you use e-tag header, you can still check from with the server that is the cache still valid and you can serve it. But for must revalidate, it will always serve from the server. So that's a major difference. There are other directives also, but yeah, we are discussing these many. Coming to the cache validators. So as I mentioned, e-tag, right? That is used with no cache. So what does e-tag do? So server sends this header with a unique random number. When I say number, it's not just number, it could have alphabets. I mean, we can check that, but it's a unique string basically. Right? And once the max age expires on the client will send if none match header with the same random string that was generated as a tag. Now, what the server will do? The server will see whether this particular set, let's say it's for an image. Let's say that the image was cached and now the image cache time is expired. It will check whether the image has been updated or not. If it is the same, right, it will tell the client that you can renew the cache's max age again. So it is now valid for the same max age it was previously. So basically, it was just sort of validation just to check whether this particular asset is updated or not. That's what e-tag is used for. Okay. Now that was mostly about HTTP and its headers. Now we'll talk about how to optimize your load time and mostly your first load time. But before we deep dive into how to optimize your first load time, we need to understand what are we optimizing it for. What are different steps that are happening in the browser once you send your HTML. So we'll be learning about something which is known as critical rendering path. Some of you might be already aware of it, but for those of you who don't know, this is the entire process that happens at the browser side when the browser receives your HTML, CSS, JavaScript, basically whatever assets are there. So the first step that happens is the construction of HTML DOM, which you might or you would have heard what is DOM, right? So your HTML DOM is first constructed. Okay. Second step is the construction of CSS DOM. So just like HTML is its object model, CSS is its own object model. So the CSS object model is constructed, right? The third step is combining this HTML DOM and the CSS object model and constructing the render tree. So render tree will actually have all the details, what is actually going to be rendered on your screen. Because some of the things in your CSS could be visible null or displayed and something like that. That could be some tricks, right? So that could be some other overlays that you're doing in your CSS, some stuff. So the ones the CSS OM and HTML DOM are combined, then that comes the render tree, which means what you are actually going to, what the user is actually going to see on the browser. Okay. Third part is layout. Now, what does layout mean? Let's say the user is on a 14-inch screen. So for him, the placement of different things like an navbar, body, aside, whatever it is, will be at different position, different pixel levels. Let's say this another user is using the same website in mobile. So for him, the screen is small, right? Again, placing the different contents at different places. If it is a big screen, right? Let's say 32-inch monitor. For him, the layout will be different. So the calculation of layout happens at this stage, which is layout. And the third and the fifth and the final part is paint, right? The colors, whatever are there, the painting part of the browser that happens. So these are the 5 different steps that are involved in the critical rendering part. Trust me, this is very, very important. It will help you. It will be asked in most of the interviews if you're going to any for 2+ year experience. I mean, it could be even for less, but for any senior engineer, this is definitely asked if you're going for a front-end developer. And you should be very well aware of how this works. Okay. So these are the different parts that are involved in that. Now, how do you optimize? Okay. So basically, there are different ways. Okay, we'll be talking about some of them. So we will optimize the render blocking assets. What are the render blocking assets? So I will say, so basically, if let's say your HTML, you're parsing your HTML, and you come across a script tag. Okay, now the HTML DOM construction will stop, and it will start downloading the JavaScript and then parsing the JavaScript. Okay, that happens. That is render block. Similarly, if you're using CSS and you're using some web font, some Google font, so it is constructing your CSS OM. It comes across some Google font. Okay, and what will it do? It will stop the CSS OM. It will block that render cycle, and it will first download the font, then parse the font, then continue. So these are all known as render blocking assets. So optimize them. What does optimize them mean? Optimizing them means you can preload them. So even before the critical rendering part starts, right, you can preload these assets. How to do it? It's done with a resource hint, which is with the same name, preload. I'll show you that. That will come in the comments, basically in the next slide. But yeah, that's how you can optimize your render blocking assets. So anything which is blocking your rendering path is a render blocking asset. It could be your JavaScript, it could be a CSS, it could be any image, right? If it image is taking time to download, it's a render. Right? Even if it's not taking time, basically, if it has to download, it is taking, it's blocking your render. Right? Now, what is the second thing you can do? Preload your above the fold images and fonts. So it's the same thing, same continuation. Now, what does above the fold mean? So let's say if you are on this page, let's say hacker news, what I can see here, okay, in this screen, that is my above the fold. Now what I see after scrolling, that is below the fold. So you should always optimize for above the fold. So whatever the user will see in this when he visits your website without scrolling, that is your above the fold. Okay, so you should preload those images, those fonts, those any assets, right, which are going to be there in above the fold before the critical rendering path starts. Okay, so that's preload, right? Then defer any non-critical JavaScript and CSS. What are non-critical JavaScript? One very important non-critical JavaScript which is there in every B2B application or B2C application, which are third-party scripts. Okay, analytics, okay, error tracking, whatever. So all those are non-critical. They are not required to load on their first load. It's the first the user should be able to access, then only they will do some analysis, right? So you can defer those. How? You can use the defer attribute in your JavaScript, in your script tag, basically, right? So these are the different ways you can optimize your CSS. Sorry, no, optimize your critical rendering path. Okay, so if you would have heard of defer attribute, async attribute, all those attribute with script tag. This is the actual purpose of it. This is actually what it does. It will help you unblock your critical rendering path. Okay, and hence improving the first load. It nth load, any load, but most importantly, the first load time of your website. Right. Now coming to the next slide, which is going to be the last slide of this session. So we are going to talk about how can you optimize the first load times. Okay. First thing that we already alluded to, which is preload, prefetch, okay, basically resources. So one of them is preload. So let's say you know that there are certain images that you are going to load on your website on the above the fold part. Okay. So what you can do is you can have a tag, link tag. You can add the link to it. Okay, and you can have the preload attribute in that link tag. So that will preload that asset before the critical rendering part starts. Second, you can do prefetch. What is prefetch? What is different between preload and prefetch? So let's say you are currently in your carts page. Let's say you are in a shopping website, online shopping website. You are on a cart page. Now, most probably, the user is going to look at checkout page. There is a very good certainty he'll go to checkout page. So what you can do is you can prefetch the assets required for the next page once the asset for current page are downloaded. So let's say you are on the cart page, its assets are downloaded, it's rendered properly. Now the network is free to do anything else. So the user is still checking the cart, he's checking like, okay, if everything is correct or not. Meanwhile, what if you have a prefetch attribute attached for the next page's assets, it will start downloading those assets. So as soon as the user clicks on the checkout page, everything is already downloaded. It will be instant for the user. So there is prefetch. Then there is pre-connect. Now, what is pre-connect? So basically, as I told, for any HTTP connection, you require a TCP connection, right? For any HTTP request and response, you need TCP connection. So let's say you know the user is going to click somewhere, okay, or in the next page, he will be requiring some connection with another API. So you can do pre-connect. So that the TCP connection between the client and the server is already established. And once the user does that action, and then the HTTP request will be sent right away. So this is pre-connect. All of these are known as resource hints because there are different resources that you're trying to optimize for. Okay. Then there are script attributes which are defer and async, which most of you would have already come across in the interview questions, or would have definitely known what is defer versus async, right? So that is used with your script tag. Right? Then coming to next part, what you can do is you can minify your assets. So basically zip it, right? Basically gzip, or you can sort of any sort of minification thing. There are different algorithms like broadly something which are there, which can be used to minify your CSS, minify your JS bundles, so that that request and response has a lower KB of data to be transferred, right? Then there is bundle size budgeting. The what does this mean? It is similar to what the above point is. That means is that you have a budget of your website JS bundle, a budget of your website CSS bundle, that it should be always 100 KB. So till you are developing, let's say it's 80 KB, it's good, 90 KB, it's good. As soon as it start reaching 100 KB, you need to think about how you can optimize your JavaScript, how you can make it so that it doesn't increase 100 KB. You can start, you can even think of entire restructuring of your code, or you can think of removing some assets. Let's say you have included the images in your JavaScript code, which no one would do, but let's say you have done it, right? So you can move those images to CDN. So that will decrease your bundle size of the JavaScript. But that means budgeting of your bundle size. So you should keep that budget. That our budget of the JavaScript bundle should never cross 100 KB or 1 MB or whatever it is. That depends on your architecture, because there will be certain amount of JavaScript that you require to send. You cannot cross that level threshold. But yeah, that's what budgeting is. Then coming to the next part, optimizing images. Okay. Now this can be done using different formats. Again, it depends application to application. Right? There is a very good format which is optimized for like it in lowest amount of data. It can have the highest quality, which is WebP. But again, it might be supported in some browsers. It might not be supported in some browsers. So you have to choose. You can see whether it is suitable for your needs or not, suitable for the clients that they are using. Then you can lazy load. Okay, now in the image tag itself, we have the attribute lazy load images, right? So you can lazy load your images. Okay? You can do that. So as and when the user scrolls, as and when the user comes to the viewport, at that time you can load it. Okay? You can do a different kind of optimizations with images. The next part, which is long running tasks in your JS, right? There will be some calculation that you are doing, right? Some kind of API call which is taking long time, which is synchronous API call. In all those kind of things, let's say sorting, because when there are tabular data involved, sorting, filtering, if there is hundreds of rows of data involved, it takes time. What you can do is you can either memoize those sort of functions if it is possible to memoize. Okay, what does memoization mean? Meaning, let's say you want to calculate the sum of two numbers. And we're giving very simple example. If you want to calculate sum of two numbers, let's say 2 plus 4, 6. Next time, user again does the same thing and the same sum is getting calculated, 2 plus 4. But it takes, let's say, for example, 3 seconds to calculate that. But user already did that earlier. Why do I need to do it again? So you can memoize that function as such that that 6 value is cached for every time the input is 2 and 4. So that is what is known as memoization. So memoize your code. Another is use web workers for anything which is like which takes long running task and cannot be memoized. Let's say filtering, sorting. That is practical thing that I have used in production applications. Right? These for this kind of thing, sorting and filtering, I had to use web worker, right? Because it was client side sorting and filtering, and it was having hundreds of rows of data. So I have personally used this. Right? So I'm giving you a practical example here. So you can use web worker for that. Okay, web worker is just another thread. So when you're executing anything on your web browser, web page, it is having a main thread, main JavaScript thread, which will run your code and everything. What you can do is you can have another thread, okay, which can do all your heavy tasks, which you can assign to your web worker. That will be a separate thread. Okay, they can communicate between each other. You can send the data. That is the data you have to calculate. It will do it calculation, run its JavaScript, and then it will send it back. Okay, this is the result. Okay, it's a very simple API. You can go around and play with it. It's very simple API. Okay, so that's what you can use to optimize long running tasks. Okay. Next point is resource delivery. So most of the JavaScript stuff, most of the front end stuff, which is our CSS, images, even JavaScript, does not change over time. Okay, let's say even if let's say you are having after every two sprint you are releasing something, still for 2 weeks your bundle might not change. So all those kind of things, right? You can put it in a CDN. Now, what are CDNs? CDNs are like, so basically servers. What servers are basically, servers have to do some kind of computation. So basically, whenever a client request, they have to do some kind of computation and they have to return the data. What are CDNs? CDNs are like client will request and it will just send it back immediately. So anything which does not require any sort of calculation, you can store it in CDNs. And CDNs are also deployed at multiple places compared to server. So let's say in a country, let's say, let's example USA, there are 7 different servers in this different location. You can have 17 different CDNs, which are even more densely located. So CDNs will be better in that case. In case of static assets, which are not going to change over time. Okay, at least certain period of time. So you can optimize your resource delivery. The last thing that we can optimize is third party. Third party shares like analytics. Okay, any sort of analytics, any sort of tracking that you're doing for the user stuff, even for your own performance checking. For web vitals, we have that. We track it via some in let's say if you're using Azure, you're doing any sort of portal. If you want to track your performance matrices, so all those JavaScript, these are very non-critical, right? But you still require it, okay, because it is giving you some additional benefit, right? So you can use some tools like Partytown. The Partytown is very, very recent. Okay, so what they do is they run your third-party scripts in a web worker. Okay, so you can use some solution like Partytown. Even your own company, some other companies have their own solution of handling these analytics JavaScript, which are non-critical, but obviously we need to run it so that we get some data input from the user's behavior. So yeah, these are the different ways. I know this was a very theory heavy session. I am very much aware of it. Maybe you can have a follow-up session where I can deep dive into different stuff like HTTP headers, how to achieve these fast load times with practical examples. But that will be need to have a separate session, which are hour or 2 hours long sessions. So I can practically explain what everything is. So yeah, that's the most of the things that I wanted to discuss in this session. If you notice, I did not mention any of the framework. Okay, I did not mention React or anything because I wanted to keep it the fundamental. This can be used in any framework. Today it's React, tomorrow it will be something else. These fundamentals will remain the same. The way you do it, it will be different, but fundamentals will remain the same. Right? So now I think we can take up any questions if they are there.
Yeah. So the people who are joining us from Zoom, you can type down your questions in the Q&A tab, and the people who are watching us on LinkedIn Live, please do drop your questions in the chat section, because I'll just go ahead and have a look at the chat section, and if you're having any questions, I'll make sure that I'll get it to the speaker today. So one question we have, and it says, how can you use HTTP to implement a RESTful web service?
So basically, RESTful web service is like, how do you use, how to transfer different sort of request. Basically, let's say if you want to just get some data, okay, you are just requesting for some data, and so you can use the get method. If you are updating something, okay, you can use put. If you are deleting something, then you can use delete. So REST is just a standard procedure, I would say. Okay, there are other ways like GraphQL and the RPC, gRPC. So there are different ways. So that is just a procedure, and most of the HTTP APIs will follow the REST APIs that are currently existing. So you don't have to do anything special to follow REST APIs. Okay, as I showed you, I can just go back to my slides here. If you see here I'm using this get. What is this get? Get is a sort of method which follows the process of REST. Okay, and I'm using that to get my resource. Now, how do you actually implement in the code? If that is your question, that depends on the platform that you're using. If you're using Express, right, or if you're using Node, there's a different way of doing it. Okay, you can just use app.get and you can specify the path and then you can do like that. Okay, if you're using Spring Boot and other stuff, there's a different way of doing it. That is very much framework specific, but otherwise, it's just like using the different methods that are there available in the process of REST.
Okay, we have one more question, and that says, what are the advantages and disadvantages, I think, of using HTTP 2 compared to the previous version of HTTP 1? I think he's asking the overview of HTTP 2 when compared to HTTP 1. Yeah.
Yep. So what I would say is if you have a very simple application, okay, let's say like a blog or something, where you are not, I would even call it application, it's website. It's a website where you're just rendering data. It can be images and it can be anything, but you're just rendering data. You're not doing any interaction. Let's say you're not doing any filtering, sorting, any type ahead or anything like that, like autocomplete or any Google search, anything like that. If you're not doing it, 1.1 is the way to go, because it is it will have a persistent connection. Okay, and you just have to deliver the HTML, CSS, CSS images and all those stuff. If your use case is a web application, okay, let's say YouTube, Google, okay, anything which does involve a lot of back and forth between the client and server, okay, in that case, or if you have some application where you require communication from the server to the client without the client asking for it. The client send notifications. If you want to send notification on your web, right, something like that. In that case, you should go for HTTP2 because it has multiplexing, it has server sentiments, it has header compression, it is better. Right. So depending on your use cases, you can use either 1.1 or 2.2. But never be in that assumption that because we have a next version, we should always use 2.0 because it comes with its own overhead also. Okay. So see your use case and according to that, use the version.
Yeah. We have one question in our Q&A tab from our Zoom audience, and it says, "Hi Purv, it is a good session. How do you configure our HTTP to 1.1 or 2 in that our application, like that our application?"
So yeah, a very valid question. I actually wanted to demonstrate it, but given the time constraint, I could not. Maybe in another session, but I'll tell you how to do it. That your node server, basically. Okay, because I have worked in node, I would say in node server, but basically any server. What you can do is when you send the response, right? In the response times you can negotiate. This is the version that I'm going to follow. So if you, even if I did mention that in earlier. The HTTP response message format, the version of the HTTP protocol that the server follows. So the server will set it up. The client would not know in advance that which version do you follow. Obviously, I mean, whenever you're developing an application, the front-end developer and the back-end developer will know what they are following. But the client will never be able to dictate that what version to follow. It will be the server. So the server has to, when it responds, it has to say 1.1 or 2.2. And there will be protocol negotiation. Again, there's a separate thing. Okay, you can check it on internet how that negotiation happens. But whatever the server said, let's say the client said 1.2 and the server said 2.0, or if the server client said 2.1 and the server is saying no, I only do 1.1. Okay, so then a negotiation happens and then it works. So basically, when you're responding from the server, you set the headers. You can use Express, you can use plain Node HTTP server, and in that you can set headers. So in the headers, you can mention the version of your HTTP, and that's what will be negotiated, and that will be followed in the following communication.
Yeah. I think we have one more question. In network tab, where can we see HTTP version?
So it depends on browser to browser, right? So if you see here, this is a Firefox. So if you see here, if you click on the request, each and every, if you go to network tab, you click on the request, and if you scroll a bit in the header section, you can see which version it is. In Chrome, I believe it's here itself. Okay, it's one of the sections, like we have the status and method and domain and file. In Chrome here itself, you can see whether which version it is for each request.
Yes, and a question from Jason. Proxy versus reverse proxy, it is very confusing. Let's say I'm doing reverse proxy in client side. Is that a valid statement?
No, reverse proxy is always server side. So again, because I did not go into depth of it, so you will definitely have a query about it. I mentioned it because we were talking about caching, and I was talking about public caching. But in order to understand it in depth, you should definitely Google about it. There are good tutorials on YouTube and on the web dev. Um, because of that time constraint, I did not go into depth of it. But yeah, the reverse proxy cannot be used on clients and it's on the servers.
Yes. I think one last question. Just having a look at the question in our live chat. Guys, if you're having any questions, we're going to take up since in 1 to 2 minutes because I think we are done with the presentation almost. And audience question is what we're taking right now. And if you're watching it on live, please drop your questions in the comment section of our live. Okay, how can you use cookies to implement personalization and tracking features on your website? And what are the ethical and privacy consideration involved?
Okay, so that depends on you. My answer will start with depends, but it is like when you are having first you need to have the need. Okay, if you have that need, then your company will have a standard procedure for doing it, because there are lots of laws that you have to follow, GDPR laws, and there are different laws that you need to follow. There are certain things that you can track, certain things that you are not allowed to track. Okay, so if you have to track, what you can do is basically the browser cookies, right? There will be some sort of I would not say exactly shared cookies, but there are some sort of shared cookies which different website will share amongst them. Okay, so you can access those. Okay, and then you can get to know, okay, this person follows this page on Insta, this person buys this thing on Flipkart or whatever it is, and then you can get the personalized details of them. Okay, that okay, if he visits this website, he likes this. If he visits this website, he can like this, and that's how you can get that. Okay, this is very much I'm talking in a brief level. I don't know in depth. What I use is I use when had to use in the company, I use their library which used to do it for me. Okay, so but this is how it works is what my understanding is, and but it is very much critical to follow the laws. Okay, so if you have to follow the law, you need to talk to a security team. They will be more knowledgeable on that stuff. I don't have that much knowledge how what data can you track and what you cannot track, but you need to talk to a security team, and that's how you do it. If you're doing it on your own, then you need to do your own research. If you're doing it for your own startup or for your own hobby stuff, where you want to use cookies for a project, then you have to do research on it.
Yes, we have one more question. How do we lazy load images while loading your page?
Got it. So there's an attribute. Let me just check for it. MD and IO. Where is this? I check up here. So there's an attribute in the image tag where it will tell you can this image will be loaded in lazy manner. Basically, it will load when the user scrolls, or it will load. It will not load, or it will not block the render path. Basically, I'm just searching for that exact one. Same. Yeah, here it is. It's lazy. So you just have to use this lazy attribute, and that will make sure that it is loaded lazy. Do we have any other questions?
No, I think that's the last question. Yeah. I think that's the last question. And I think someone has shared one last question. No. Yeah. Well, that brings us to the end of this wonderful session, guys. I hope that was the last question. And if any of your questions are unanswered, I'll just give 10 to 20 seconds more. If you're having any questions, please do drop your questions in the question like a Q&A tab. And if not, I think we are good to go, and I think we can end the session today. Yeah. Okay, that was the last question, and that brings us to the end of this wonderful session. I would like to thank each one of you for joining us. Hope you learned something new from today's session. We look forward for your post on LinkedIn along with your key learnings and takeaways from the session. I did drop the LinkedIn post in the Zoom chat. So please go ahead and show some love on the post and let us know what are your learnings and takeaways from the session. And if you want Apoor to take any deep topic regarding the same thing, let's say HTTPL caching or anything else that he thought today, if you want any advanced level of that, let us know in the chat, and we would make sure that we'll have Apoor for another advanced session on the same. Also, thank you so much, Apoor, for joining us. Thank you for taking out time from your hectic schedule and preparing the whole presentation. It was really amazing. And thank you so much for sharing your valuable knowledge and experience with us.
Thanks for inviting me again, and it's always a pleasure sharing my knowledge.
Yes, likewise. So before we end this session, guys, we have a few announcements to make. We have created a community for developers called Rebase on Discord. That is a closed community just for working professionals of 2+ years of experience. And if you're someone with 2+ years of experience, then you can get a chance to connect with the fellow developers, have mentors, and get career opportunities and ask for help. So the link to the Discord, I'm dropping it in the chat, so you can just go ahead and join the Discord server, Discord channel, and then you can go ahead and say hi to the audience over there. And I have dropped a feedback form in the chat and also on the LinkedIn live chat. So do let us know your feedback on this webinar and what do you like the most and what's something that you want a little advanced topic on. And we would love to have Apoor on the same topic discussing the advanced level on the same thing. Yeah. And if you have any questions, follow and connect with Apoor. He'll be more than happy to connect with you and help you out with your queries. He also has a YouTube channel. He gives active webinars and speeches, and do follow him. And he also has a blog. Apoor, can you share your blogs that you usually write it on tech? Do follow his YouTube channel also, guys. He talks and helps developers according to the same. And he has trained and helped over 100+ students and made them a better developer. So he can help you with any queries and suggestions. If you're exploring career opportunities, Recro is hiring passionate developers. Do check out the current openings at Recro. You can go to the link that I'm dropping you in the chat, and that is recro/career.io. If you're looking out for a change, if any of your colleagues and friends are looking out for a change, make sure that you explore the opportunities at Recro, and we'll make sure that we'll place you in the top A-grade startups of the country. To stay updated with such events, follow us on social media. Follow us on Instagram, LinkedIn, and YouTube. And the live of this webinar is already on LinkedIn and YouTube, so you can just go ahead and have a look at the live. In case you missed any pointers or any slides that Apoor was presenting, until then, this session is recorded and we are going to edit it and then post it on our YouTube channel of Recro. So do subscribe to Recro's YouTube channel and be updated to such insightful events that we are going to host in the future, and also the one we have hosted in the past. So that's all for this session, guys. Thank you so much for joining us. Take care, stay safe. Thank you so much. Thank you so much for joining again. Thank you so much, Apoor.